rational functions are functions where the numerator and denominator both are polynomials. So you have a rational function Rx, which is of the type of Px by Qx. Here Px and Qx both are polynomials. Now, one of the most important aspect of rational function is asymptotes. Whenever you have a rational function, you must have asymptotes in most of the cases. First of all, what is asymptote for a rational function? Asymptote is a line of the curve where curve doesn't meet the vertical asymptote, especially curve doesn't meet the line, but it goes nearer and nearer and nearer to that particular line. Horizontal asymptote, yes, it can cut the line also, but here also the property is that ultimately it will go on, very close to that particular line, and then ultimately at infinity or negative infinity, it will meet the line. Now, that's your asymptote. It's something like this. I'll give you a small example. Y is equal to 1 by x is my function, which is known as a rectangular hyperbola. It's a rational function naturally, and they are polynomial, which, if you draw it as a curve, it's like this. You can see that here the gap is this much. As you go close to this line, it's closing like this, and so this. So distance is reducing actually. Okay. So this line is basically horizontal asymptote of y is equal to 1 by x. Similarly, this line is a vertical asymptote of y is equal to 1 by x of the rectangular hyperbola. So asymptote, you can have horizontal asymptote, you can have vertical asymptote, you can have oblique asymptote also. But as far as this SAT level 2, mathematics 2 is concerned, only horizontal and vertical asymptotes are important. Therefore, I will discuss only these two asymptotes. Now, horizontal asymptotes you can always get by taking Qx to be equal to 0. Okay, only one thing you should remember, that particular factor, linear factor which you are taking, that should not be a part of numerator actually, right? So that is horizontal asymptote. Let's take a small example again. Now, suppose my rational function is, x into x minus 2 divided by x minus 1 into, let's say, x minus 2 again. Now here, if I take Qx or the denominator to be 0, what are my values? One is x equal to 1. Another value will be x equal to 2. Now x equal to 2 is not an asymptote. It's not a vertical asymptote. Reason being that you have a x minus 2 factor in the numerator also. Therefore, this rational function is having only one asymptote, which is, vertical asymptote, x equal to 1. Now, if you come to the second aspect, that is a horizontal asymptote. How to find the horizontal asymptote? Now, horizontal asymptote by definition will be equal to, y will be equal to, as you know that the horizontal means the equation should be y equal to some number. Now, that will be equal to limit x going towards infinity or maybe negative infinity also of this Rx. That will give you an equation of horizontal asymptote. Again, in this particular case, if you see, let's take another example where you have to find horizontal asymptote also. Let's take, x square plus 1 divided by x square minus 1. Now, as I explained earlier, that your vertical asymptotes are x equal to plus 1 and x equal to negative 1. Now, in this case, if you take limit x going towards infinity, you will find that the horizontal asymptote will be y is equal to 1. So, in this particular case, this rational function, your vertical asymptotes are x equal to 1, x equal to minus 1, and horizontal asymptote is when limit of x approaching infinity, which is actually y is equal to 1.